Okay, so we're going to do November 2020 question paper, question 3, mathematics paper 1. So the first question, which is 3.1, read as follows. Prove that the sum of this sequence from k is equal to 1 to infinity is a convergent geometric series. Show all your calculations. I'm going to read it again. They are saying prove that this series is a convergent geometric series. Show all your calculations. First question that you ask yourself, what is a convergent geometric series? Or in fact, let's start there. What is a convergent series? So, a convergent series is a series in which when you take the sum of partial terms are getting closer to a specific value. Which means now, if you're summing the terms, let's say you sum 7 terms of this series, and you sum 20, and you sum 40, sum 100, sum 500, and then, so let's say now, you have the sum of 4 terms, sum of 7 terms, sum of 50 terms, sum of 70 terms. So, I'm trying to explain what is the convergent series here. So now, a convergent series is a series in which when you take this sum, and you take this sum, and you take whatever sums that you can think of, they all seem to have to be getting closer to a certain value. Let's say, for example, here, when you take sum of 4 terms, you get 3.1. And then when you take some of these ones, get 3.11. And then for the next, 3.114. Then 3.115. So if you look at this, so this is the sum of 4 terms. This is the sum of 7, sum of 50, sum of 70, sum of whatever number that you think of. So if when you take the sum of these terms, whatever number of terms that are on this series, the value that you get is always similar, then you say that that sequence is convergent, because as you are adding the terms of the series, those terms are adding up to a specific value, and that value in this case is around 3.1. Because you can see you have 3.1, 3.11, 3.114, 3.115. So whatever value of the terms, whatever number of terms of this series that you want to add, you will see that they will be adding up to a specific value, or getting closer around the specific value. So in this case, they're adding up around to 3.1. So this is the sum of 4, sum of 7, sum of 50, sum of 70. So the convergent sequence is a sequence in which the partial sums of the sequence are getting closer to a specific value, or approaching a specific value. By partial sums, I'm saying that you can sum whatever amount that you can think of, not the not all the terms that are in the series. So that is what a convergent series is. So what is a convergent geometric sequence? So that is what is important. So a convergent geometric sequence, first of all, it must meet this property, which means now when you add when you're taking the partial sums or adding specific number of values of the series, they must be getting closer to a specific value. So this is what this means. So that's what convergent means first. So in this case, they are saying that we must prove that this series is a convergent geometric sequence. So first of all, you must pass that property that I just defined. Second part, for a geometric sequence to be convergent, the common ratio for a geometric series to be convergent, which they call R, must be less than 1 and greater than minus 1. This is the condition that you need. For a geometric series to be convergent, the common ratio of this series must be greater than minus 1, the ratio must be greater than minus 1 and less than 1. That is what you need. So now the next step that we should do is to find if this ratio does indeed fall between minus 1 and positive 1. And if it does, then that's what we need. Because for a geometric series to be convergent, we must have this condition. So once you get this condition, you can be confident and say, yeah, I know that this series converges because the ratio is bigger than minus 1 but smaller than 1. That's what a convergent geometric series is. So let's go. So now the first thing that we do is to find the terms of this series. So this series of R1s, which is this, which is infinity, k is equal to 1, of 4 times 3 raised to minus k. So for k is equal to 1, then you sub 1 there. So you have 2 minus 1. And 2 minus 1 is equal to 1. And then now you have 3 times 4, that is 12. Plus, it's a series. Then now you proceed, go to 2. You substitute 2 there. So it's going to be 2 minus 2, which is, now you are done with 1, you are going for 2. So 2 minus 2, that's 0. So 3 raised 0, 3 raised 0, that's 1. And then 4 times 1, you have 4 here, plus, continue again. You substituted 1 and got this, you substituted 2 there, you got that. Now you put 3. These are enough, but I'm just doing it for fun now. So when you have 3, you have 2 minus 3, that's negative 1. What does that mean? That means now we have 4 times 3 is negative 1. So that is 4 over 3 plus the list goes on. So this sum goes on because it's going to infinity. So the sum continues. So the next thing is to find the ratio. The common ratio, which is R, is equal to T2 over T1. This is enough. Or you can say T3 over T2. In this case, what do we have? I'm going to use this one. It doesn't matter which one you use between the two. So T2 is equal to 4 over T1, which is 12. This is 1 over 3. And when you look at the value of 1 over 3, 1 over 3 is 0,33333, and so on. So this value is bigger than minus 1 and smaller than 1. Therefore, this sequence is convergent. So you say, okay, R is equal to 1 over 3 is less than 1 but greater than minus 1. Therefore, the geometric sequence is, series, geometric series is convergent. It ends here. So your R, which is 1 over 3, is greater than 1, less than 1, is greater than minus 1, less than 1. Therefore, this series is convergent. We are done with this. That's what they wanted you to see. Now, we go to question 3.2. If the sum of this series is equal to 2 over 9, determine the value of P. I will read it again. if this series, if this series is equal to 2 over 9, determine the value of P. So they are saying that when you evaluate this series, or you calculate the sum to infinity of this series, it gives you 2 over 9. So they want you to find the value of P. So you have that the sum to infinity of this series is equal to 2 over 9. So what they want you to do is find the value of P. So in the previous question, we already established that the common ratio of the geometric series is equal to 1 over 3. That's what we established there. That's how we concluded that this geometric series is convergent. Because we say in order for a geometric sequence to be convergent, the common ratio must be between 1 and minus 1. It must be in between 1 and minus 1. And this number here is in between that. So, yeah, we have this. Second question, we know that the sum to infinity of a geometric sequence is equal to A over 1 minus R. So, we have the sum to infinity of this. It is 2 over 9. We have the common ratio, it's 1 over 3. What we don't have is the first term of this series. So, the first thing that you have to do is to find the first term of the series. So, let's work on that. So, the sum to infinity is 2 over 9 is equal to A over 1 minus 1 over 3, which is equal to A over 2 over 3. So, you cross multiply this times that and this times whatever. So, it is 4 over 27 is equal to what? Is equal to A. That is the value of A. Because it's going to be this term times that term. And this term times 1, which is below 2 over 9. So, you have that your A is equal to what? Is equal to 4 over 27. That is the value of A. The next thing that you do is to say, okay, I have my A value, which is the first term of this sum. So this A that I have here is the first term of the sum. How do you get the first term? In order to get the first term, you substitute this P there, then you get the first term, which is A. You know, when you evaluate, so look at the previous question. I evaluated this. There was 1 here. To get the first term, when K was equal to 1 on 3.1, I substituted 1 there. I got the first term to be 12. And then I went to the second term, which was 2. I substituted 2 there. I got 4. So, to get the first term of the sequence, I must substitute this term that I'm giving here, the starting point of the series, where the series begins. And it begins at P. And 3.1 it was beginning at 1. That is why I substituted 1 there. But now, it's starting at P. So the first term that I'm going to substitute there to get the first term is P. So let's work on that. I'm going to clean this, because you don't need. I'm going to take this up here. So A is equal to what? 4 over 27. This is what we just calculated. So, let's go on. So, to find the first term, we must substitute P there. So, that means we have 4 times 3 raised to minus P is equal to what? Is equal to 4. Oh, so when you do this, this will be the first term, because that's where the sequence begins. And this is equal to this 4 over 27. So we want the value of P, divide by 4, both sides. We are left with 3 is equal to 2 minus p, which is equal to 1 over 3 raised 3, that is 27. So take this, put it up there. So it's 3 is equal to 2 minus p is equal to 3 raised negative 3. So for these two terms to be equal, which is this, the left hand side and the right hand side to be equal, they must have the same power. Which means now the value of this, in order for this 3 raised minus 3 to be equal to this, which means the value of this must be minus 3. I'm not sure if that makes sense. So if you're saying you raise 3 by minus 3, and you ask what must you raise this 3 this side to get minus 3, which means you must also, or in order to get the same number as this, you will have to raise the same number. So now I know these two numbers are equal, are the same. So now I'm going to investigate the value of this p I need to get minus 3. So you equate the exponents, which is 2 minus p is equal to minus 3. Which means now your minus p is equal to minus 3 minus 2, which is your minus p, or which is equal to minus 5. Therefore, your p is equal to 5, because you're going to divide with the negative sign, both sides. So this means that in order for you to have a sum to infinity that equals 2 over 9, your starting point of this series, you must start summing the terms of this series at k is equal to 5. That's what this means. And this is the end of this question. Not difficult. Not difficult at all. So yeah.